Welcome back to the shop. This time we will work on the magazine springs for my miniature M1911. I already did some testing prior to this, and I just pounded 2 nails in a board and wrapped some 0.5mm spring wire around it that I annealed to make it soft, because spring wire, when it's hard, it's hard to bend it. That's why it's spring wire, and I get pretty good results by this. The springs even fit into my magazines like this, and I heat treated them after bending, and they have some spring to it again. I have to work out the heat treat in the end, because very often it happened that the spring broke in one area, but I will figure that out one way or another. But first I need to make a jig to wind these springs. I will make a jig that allows me to wind these springs on the lathe, because as I did it here on the bench, I needed 5 hands roughly, and on the lathe I can chuck the jig, spin it by hand or with low RPM, and feed the wire through the tool post. That might give me way better results. So let's get started, get over to the milling machine and make a jig. We're over at the milling machine, and I already have 2 pieces of 10mm phenolic sawed up, and I'm going to square these pieces up. I don't need them to be accurate, they should only be the same size and square all around, so I can proceed on. Yeah, that stuff machine's very nice, but the dust it produces is pretty nasty. Okay, 4 sides are squared up. Now we're going to side mill the end surfaces. Now we're going to poke a hole in the middle, and we will press in a 4mm dowel pin that can be chucked up in the lathe. The other part will get center drilled, and then we need 2mm holes in both pieces. I have centered on the part, and I'm going to use a center drill to start the holes, the 2mm holes, and to put a center for the live center of the lathe into the middle of the part. Pulling out the parallel because I'm drilling through. Okay, we have all the parts for the spring winding jig ready. The 2 end pieces out of phenolic, 2 pieces of 2mm drill rod, and a 4mm dowel pin. We'll use the good old super glue to assemble it all. When I'm done, I'm going to wind these springs around these two posts, and then I need to slip off the spring off those posts, but I can't because I just glued on both pieces. Yeah, that's me in the shop. I'm going to remove this piece again, clean the holes from the super glue and put in 2 set screws on the sides so I can clamp it on the posts, wind my spring, loosen the set screws, pull off my end piece and pull off the spring. Okay, I changed the design of the winding arbor, maybe it can be called an arbor, and now the end piece is locked on with 2 set screws. So I can pull this off, pull off my spring when it's wound, and then put back on my end piece. I have about 20 meters of 0.4mm spring steel wire, and that might give enough material for some try. Okay, we're over at the lathe, and now we're going to put the winding jig into the chuck, clamping on the 4mm dowel pin, pulling in our tailstock and supported with the live center. Now we have these 2 posts where we can wind around the wire. I have the wire here. It's a 1 meter piece of 0.4mm spring steel, and I'm feeding it through the tool post using a piece of soft wood, and I hacksawed a slot into it. I'm feeding the wire through the slot, and I'm using this like a brake. I'm going to clamp this. As you see, I did it already. I clamp it in the tool post to give it some drag when I pull the wire through. So I'm just giving it some tension. As you can see, I'm pulling the wire back and forth while I'm adjusting the screws on my tool post to find the right setting. And I'm going to bend a small loop on the end of the wire. So I can hook it around one of the posts. Okay, there we go. I can tension the wire by just pulling on the wire behind the tool post. And what I'm going to do now is I'm using my little propane torch, and I'm going to heat up the wire, and I'm turning the chuck by hand around to wind the actual spring. I'm going to put winding against wire, and later I will anneal the wire during this process, and later I will stretch the wire out to the right pitch, clamp it up, harden it, temper it, and then I have a spring in the right dimensions. So let's go. Okay, there we go, first winding, and I have to adjust with the carriage slightly. Okay, that was the first winding. The first one is the hardest because you don't have much to hold on, and I give a bit more tension on the screws of the tool post. Okay, there we go again. Oh, yeah, and that shouldn't happen. I just burned the wire. Okay, that works better. Okay, let's cut off the excess wire. Okay, we have our mandrel with the spring here, and now I'm going to remove the end piece just by loosening these two set screws. And now I'm able to pull off the spring from the mandrel. But before I do that, I'm going to clamp it with a vise to make it nice and even. I'm using this small drill press vise, which is pretty nice piece, and I need to trim off the ends of the wire because they stand somewhere, and that doesn't do me any good. Okay, just give it a nice solid clamp, just to bend to give it some more of its form. Okay, now we're going to pull it off. Ooh, oops. Okay, and that's not good. That happened because I did the wise thing. Okay, that's bad. I'm going to push it back on the mandrel and glow it again. Maybe that will relieve the tension I just built up by forming the spring in the vise. Did you see? Okay. As you saw, the spring just turned in itself, and that's not good. So I'm going to push it back and give it a nice even glow. Just to relieve it. Cold surface, because that will cause the wire to harden actually, and that's not what we want right now. I'm going to pull off the spring again, and now as you can see, when I pull it off the mandrel, because I relieved the tension in the material, it stays as it was on the mandrel, and everything is still a bit, it's not really hot, but it's warm to the touch. So get the mandrel out of the way, get my side of the way. There we have our spring blank. But for now, this is a very nice, very even bound spring blank. Okay, I got a whole lot of spring blanks made up, and I cut them almost to length. I let them a bit long here, and now I'm going to stretch them out so I get springs like these. I already did these 5. And the process is actually pretty simple. I made this little jig with the channel here is a bit smaller than the actual spring, and there are 13 notches on the top. They are apart 4.6 millimeters, which is the pitch of the spring, and offset half the pitch down here there are 12 notches. So a bent spring, have to be a bit careful. These are anneal, so they are very soft and I could easily damage them. A spring fits very nice between these notches, and because of the notches, the actual stretching of the spring is pretty easy, and now I'm going to show you how I did it. Take one of these spring blanks. Let's see, so I can see the process. I catch one or two of the last windings with a clamping tweezer. Take my other pair of tweezers, catch the other end of the spring, and then I'm just going to pull it apart. And as you can see, it deforms slightly. And now I'm going to hand work it until it fits into my bending jig. I drop my spring onto it, and I can see that my pitch is way too narrow, so I'm going to pull them apart a bit more. And also have to keep in mind to keep it on a straight line. Okay, I'm cutting off one of the ends. This is spring wire, so you should use a pair of good quality wire cutters. You can buy wire cutters and you can buy Nipacks. The Nipacks cut piano wire all the day long and they won't get a scratch. And now it's just a matter of dropping the spring into the jig, cut the spring on the other side, and now I have my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 and a half or 13 windings. This last winding is just a half one. Cut off the end. Drop the spring. We're back. Bend this loop on the end of the spring. Take it, clamp it, overbend it to get this elevated piece. This end is already the right size. Bend it down to be in line with the last winding of the spring. And pull it in slightly. So that's the way how I bend these springs. Now I'm going to heat treat them. Okay, now I'm going to attempt to harden the spring. I welded together these two pieces of cold rolled flat stock with a gap in between where the spring fits in. I do this to give the spring some mass when I heat it, so to give me some time when I'm moving from the fire brick over to the water to quench it, so it doesn't cool down instantly. And also it gives me the possibility to evenly spread the heat. So I'm using a propane torch. Okay, now I give it a few seconds to even out the temperature and I'm dropping it into the water. Okay, just leave it in a few seconds so it doesn't anneal from the remaining heat in the flat stock. Okay, let's pull it out. Now I have to be very careful because the spring is incredibly brittle. When I try to bend it now, it will snap into pieces right away. So I have to be very careful. And I'll do this with all the springs for the magazines, and then I'm going to anneal them. I have my little oven here, and I put up my digital multimeter with a temperature probe right into the chamber of the oven. And I'm right up to 300 degrees Celsius, and now I'm going to turn off the oven. Because this oven doesn't have a temperature regulator, it's just on and off, so I have to monitor the temperature by hand and switch it on and off to get the temperature I want. And the moment I switch it off, it overshoots most of the time about 10 degrees, and then it starts to cool down. Yeah, now you can see it's starting to fall. When it's down to 280 degrees, I'm going to toss in the springs I want to temper. Let them cool down to about 200, pull them out, and then let them cool down on the air. To open the door now, and the temperature will fall down rapidly. Okay. As soon as you open the door, most of the heat goes out. As you can see now, it's still not switched on, it's just the remaining heat in the oven that's there. And we're back at 270. Now we let it cool down. It dropped down to 180. Now I'm going to open it and pull out these springs. One day I will get a real temperature controller that can do ramps up and down for this oven, and this will be a project on its own. Maybe not in the far future, because I need a lot of heat treating on small parts. So maybe this year I'll get a small computer digital temperature controller and a temperature probe that's fixed in the oven. So our springs are now out on the air, and they are already done, so you can touch them. And as you can see, they are very springy. Okay, I got six springs out of the blanks I prepared earlier, and I'm not too happy about them. They are kind of a that's not a real success. They are springy to a degree that might be usable. I'm using this mandrel to show you. Now they are fully extended, and I can spring them together and let them. And the spring action, in fact, is very nice. But I still have problems with the overall shape of the springs. After heat treating, they are warped. They have different lengths to them, and they are just not that nice. Maybe I'll do another run and make a few more of these, but for now I tried a few things, different ways of heat treating. I also put them on this mandrel, heated everything and dropped it into the water. This is the rig I used earlier with the two pieces of flat where the spring lied between, but that it wasn't perfect too. I also tried just to heat them on the air, dropping them into the water with tweezers, and that was also not perfect. Also, I burned a few in the process of hardening. I'm not sure what to do. I would love to cold form them. The spring steel I have comes in the heat treated state, and it's already, you don't have to do anything to it. It's springy like it should be, and it can be formed, but getting this complex box-shaped spring out of the hardened spring steel that's not too trivial. I will see what I can do. Maybe I will do another try on these, but for now, hope you enjoyed. This was some kind of a trial and error episode. Thank you for watching, and if you have some ideas, maybe the watchmaking guys out there, well, I would be very happy to hear your ideas on that stuff. Thank you for watching.